Thank you everybody for coming, and thank you to the organisers for asking me along today. I'm going to give a rather hybrid talk as requested. I'm going to talk about extreme events to follow on from what John was saying, and then give a few slides about ecological impacts. Some of you will have seen this slide before, but I think it's a really important one to try to explain to others, not this audience, the relationship between increases in average, such as average temperature, and increases in extremes, because I'm sure most of you will have experienced conversations where people have said, well, what does 2 degrees of warming really matter? You know, it's 2 degrees warmer now than it was at 6 a.m, though on today's temperatures that's probably not actually true. So the way we try on the Commission to explain this is using this graph. So we say to people, okay, so imagine that this graph is the distribution of temperatures over a whole year. There's some really cold temperatures at this tail, there's some really hot temperatures at the other tail, and everything else in between. And then if we increase the mean, increase the average, and just simply shift that distribution, what we do is that we lose that cold end of the tail, the hot end of the tail, the previous hot end becomes much larger as a proportion of the whole year's temperatures, and we have temperatures that we've never seen before. So I think we really have to work very hard at talking to people about this relationship, because it's, from a climate change perspective, it's a really important one. The other thing that's really new in the way we've been trying to frame the narrative on extreme events from the Commission's perspective is this. You'll be aware that there's always a lot of, every time we get a really big extreme, say Hurricane Katrina or Superstorm Sandy, people will ask climate scientists, well, is this climate change? And it's a bit like stamp collecting, I think. It's like collecting some extreme events and putting it in your stamp album, that's climate change, and others not. And what we're trying to do is reframe that message and make the point that the climate is now very different from what it was 50 years ago. The whole climate system, it's now containing more heat and more water than it did. So in that respect, all extreme events are influenced in some way by climate change. It's a very different way, I think, of framing the narrative around climate change. This graphic comes from one of the Commission's reports that we put out a couple of months ago called The Angry Summer, which was just pointing out all the temperature records as well as rainfall records that were broken in Australia over the last summer. There were over 120 climate records broken, mostly hot temperatures. And so this leads me on to just a brief description of some of the predictions about extreme events and some of the ones that we've been experiencing over the last few years. So I'm going to cover very briefly those categories there. So let's begin with heat. This graph shows the average number of record hot days in Australia over the last 5 decades. And as you can see, I hope you can see the actual line goes up and down all over the place, but if you look at the decadal average, it's a very clear trend increasing the number of extreme hot days. As I said, last summer we had over 120 climate records broken, and they were broken all over the country. It wasn't localised. This included the hottest January on record and the hottest day on record, which was the 7th of January. The Bureau of Meteorology has had to come up with 2 extra colours for their temperature maps to denote over 50 degrees and over 54 degrees. They didn't have to use those before, so the black and the purple colours are new. I'm really glad I was in Perth that day, so it wasn't too bad, but the rest of the country certainly sweltered. There was a period of intense heat. If we look forward to what this means in the future, and CSIRO have done a fair bit of modelling about how many days over 35 degrees we might expect by 2030, 2050 and 2070. And I admit I'm picking on Darwin here because I actually used these figures in a Northern Territory radio interview once, and it created much consternation in the Darwin populace, as you might expect. But this shows the number of days over 35 degrees from 2008 to 2030, 70 and 2100. And because most of Darwin's temperatures are in the 30s anyway, it doesn't actually take very much to get them over that 35-degree threshold. But basically by the end of the century, by far most of the days of the year in Darwin will be over 35. The other thing that's been happening is an intensification of the water cycle. Warmer atmospheric air holds more water, and as both the oceans and the air heats up, we get more evaporation from the surface of water bodies like the oceans. So we have a lot more water in the air, and this leads to an increased incidence of heavier rainfall events. So we've been getting flooding over the next couple of days, I believe. We are expecting considerable flooding, for example, along the New South Wales coast. There will be increases and decreases in rainfall depending where you are in the country, but most likely an increase in the intensity of heavy rainfall events, and this is a global phenomenon. But we're also expecting in some regions an increase in desertification due to hotter and more intense droughts. The IPCC special report on extremes published last year basically comes to the general conclusion, though there's a lot of regional variability, that those regions that are wet will get wetter and those regions that tend to be dry will get drier. So once again, this spreading out of extremes. Bushfires, we're familiar with this as an extreme event in Australia. We now have a catastrophic rating on our bushfire gauges that we didn't used to have. People have been looking at the Forest Fire Danger Index, especially in southeast Australia, and looking at trends over time. This is a measure of how dangerous the weather is for bushfires. It's not a measure of bushfires themselves, and have found that of 38 weather stations, 16 of them have shown an increase, a significant increase in Forest Fire Danger Index, with none of them showing a decrease over the last 4 decades. The projections for the future are quite frightening, an ongoing increase in Forest Fire Danger Index up to about 25% increase by 2020, up to 70% increase by 2050. Tropical cyclones are not expected to become more frequent, but are expected, for the ones that do occur, to become more intense. So an increased proportion of Category 4 and Category 5 cyclones is expected, and of course these are the ones that cause the most damage. And then storm surges. We know that sea levels are going up all over the globe, though once again there's a lot of regional variability. The average is about 3 millimetres a year. The east coast of Australia is about on average. Sea level, of course, is rising fast in geological terms, relatively slowly in terms of human lifespans. However, rising sea levels have a big impact on the impact of storm surges. Because the baseline of the sea is rising, a storm surge that caused a small amount of damage previously will cause a proportionally greater damage on a rising sea level, as indicated by this diagram. So there's an interaction between sea level rise and storm surges. This graphic you'll be able to get, it's in the Critical Decade report, and it just shows the intensification of the impacts expected with rising sea levels. Okay, in the last minute, I'm going to whip through some species and natural ecosystems impacts. We are already seeing, as John indicated earlier, lots and lots and lots of biological impacts. It sometimes strikes me that if a butterfly can recognise global warming, why can't some of our politicians? So I won't dwell on this. Ask me later for the details if you wish. Lots of impacts in terrestrial species, also lots of impacts in marine species, including shifts to higher latitudes, coral bleaching, etc. What we expect in the future is more of the same, but accelerating, range expansions at some boundaries, shrinkages at others, the decoupling of present-day interactions between species, and most importantly, increased extinction rates. I've often showed this slide which lists the sort of traditional iconic ecosystems that we feel are most at risk, but I actually want to make a new point today based on some other CSIRO modelling which indicates that it's really not just these ecosystems, it's just about everything. I'm going to show you two maps. The one thing I want you to note is where the map says green, it means that the climate and the environment is staying about the same. The more purple the map, the more different it is from current days. That's for 2030, a bit of purple and a bit of green. That's for 2070. That's the degree of environmental change we expect in our natural environments right throughout Australia. So I'm going to end with this depressing, as John said, we're not offering solutions here, that's what this afternoon is for. This is what we expect for ecosystems. With a 1 degree, we already know species are responding. Those impacts will keep accelerating up to 2 degrees. Once we get to over about 2.5 degrees, ecosystem collapse in some ecosystems is almost assured and ongoing after that. Sorry for the gloomy beginning.